I don't feel tardy. Yeah, time to take you to school.
Hurd class,
Learn music,
Hurd class,
notation,
Hurd class,
sight reading,
Hurd class.
theory, not to mention history. So open your ears, lose your fears, and get ready to learn to read music. Hurd's class.
Hi, welcome to Hurd's Music Class, Episode 1. Today we're going to try and do two things. We're going to introduce you to the major scale. We're going to introduce you to the origins and the construction of the major scale and some of its history. And we're also going to try and give you an idea of how Western musical notation came about, its history and how it functions. But before we begin, let's start with an essential question. Did humans invent the musical scale? Or was it some mystical thing that was always there, waiting for us to discover it? To answer that question, I'd like to tell you a story. We don't really know how it happened, so admittedly I'm just making some of this up, but it probably went something like this. One day, a caveman was walking along the beach. For the purpose of argument, let's call him Ugg. So there he is. Ugg is walking down the beach. Ugg is hungry. He's looking for food. And as he walks down the beach, he thinks his Ugg thoughts. And he goes, Ugg has conquered fire. Ugg has learned the pointy stick. Ugg is an apex predator, but today, Ugg is looking for shellfish. Looking for something delicious. Perhaps Ugg make a conch fritter. Ugg looks along the beach. All of a sudden, he finds a conch shell. Oh, Ugg find conch shell! Okay, admittedly, this is not a very good conch shell. It's an Amazon conch shell, but for the purpose of the story, it'll suffice. So anyhow, Ugg looks at the shell, and he looks inside, and Ugg very disappointed. There is no meat. Ugg still hungry. Ugg looks at the shell. He realizes there's a hole in it. A predator has come and drilled a hole in the shell and eaten the meat inside. And Ugg is disappointed, but suddenly he has a thought. Ugg try something different. Ugg blow into shell. Ugg make beautiful sound. Ugg is disappointed. Ugg try something different. Ugg try something different. Ugg try something different. Oh, Ugg like. Ugg make beauty sound. Ugg has discovered the conch shell. Oh, for added listening, I recommend Steve Teray, the trombonist from the Saturday Night Live TV show. He does this thing with shells, which is magical. I got to play a Miles Davis song with him a number of years ago, and he busted out on the shells, and it's quite something, so you can look that up on YouTube. Anyhow, Ugg discovers that if he blows slower, the lower notes come out. If he blows a little faster, a little harder, the airstream a little quicker, actually, to be more accurate, that the note will jump up. What Ugg has discovered will change humanity forever, for Ugg has discovered dun, 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 the overtone series, or the harmonic series. So, to demonstrate this, I'm going to use the trombone. In the interest of full disclosure, I am not a brass player. I'm a keyboard player by trade, so bear with me if I make ugly sounds. So anyhow, Think of this instrument not as a modern instrument, but as a tube. Just an open, empty tube. And as a tube on planet Earth, it has certain physical properties that it behaves in a certain physical way based on the reality of our physical world. So, what we're going to discover is that any tube, it could be a log that's fallen in the forest and insects have eaten the inside out, much like a didgeridoo stick. It could be a garden hose. It could be a length of pipe. If it was P.D. Cubac, it could be a lasso d'amore, which is a plastic tube you swing over your head and it makes lovely sounds. But anyhow, they all follow the same physical principle of the overtone series. So there is, in fact, a fundamental, and the fundamental is the lowest note the instrument will play normally. So I'll try and get that to come out. If you blow a little quicker, you'll get it to jump up a fifth. 1, 2, 3, 4, 5. If you blow a little faster, it'll jump up a fourth. A little faster still, a major third. A little faster still, a minor third. A little faster still, an out-of-tune flatted seventh. So then, because I'm really not a brass player, I'm going to cheat a little bit, and I'm going to take this 7C trumpet mouthpiece, drop it in here, and let's see if I can get to the interesting part of the discussion, which is where the major scale comes from. It's that upper section of that overtone series. So not a brass player, but you get the idea. What Ugg discovered that day was transformative. This scale that had been waiting for us all this time, this physical construct that exists in the universe that we live in, this overtone series was a thing of beauty, and humans embraced it, and it became basic to human nature to make music. So let's explore this physical system that Ugg discovered that day on the beach. Here's the idea. This is a vibrating system, much like a vibrating column of air, like the conch shell. Only this time it's a string. If I take the string and I cut the string in half, to the human ear it sounds very similar. It sounds like the same note, only higher. Turns out both of these are called E. This is a lower E. This is a higher E. So the question is, how much higher? And the answer is 1 octave. Well, what's an octave mean? Well, an octave is doubling the frequency of the waveform. This has twice as many vibrations per second as the fundamental. Now, to build a scale, we're going to follow a simple pattern. And that pattern is whole, whole, half, whole, 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 half. We're going to explore this on a few instruments. But the thing that I want you to remember today is whole, whole, half, whole, 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 half. Every major scale in Western music is built using this formula. So on a bass, it's pretty easy to apply this formula. A whole step, we're going to skip 1 fret. A half step, we'll play the very next fret. So, open string, fundamental. Whole step, we skipped a fret. Whole step, we skipped a fret. Half step, we didn't. We skip a fret, we skip a fret, we skip a fret, half step. So, we just showed you that the major scale that Ugg had discovered gave you this pattern. Whole, whole, half, whole, 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 half. And then we demonstrated on the bass. And on the bass, it was pretty easy to see based on the distance between the frets. You'd skip a fret for a whole step. Half steps for the very next fret. On this instrument, it's essentially going to be a little different. We're going to approach, this is big space, little space, big space, big space, big space, little space, or whole, whole, half, whole, 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 half. On this instrument, rather than going all the way up the neck as we did with the bass, we'll just try something where when we get to the 5th degree of the scale, because the instrument is tuned in fifths, 1, 2, 3, 4, 5, C, G, D, A, that will jump from this string to this string, from the C string to the G string, as we get to the 5th degree of the scale. So, fundamental, C, big space, little space. Next string, 5th degree, big space, little space. As I said, not a cellist. Had to slide up to it. And that's why string players spend so much time practicing. So the point is, it's pretty hard to play these things in tune. So if you just try, as a non-cello player to try and rip out a scale, you can see I had to slide up to that last note because I don't really know where the notes are. So for a non-player on an instrument like this, the challenges of the instrument are profound because as you go further down the neck, the notes get closer and closer together. And so that kinesthetic sense, that sense of where the notes are, is this connection between your ear and your hand. And it's not an instrument to play. So I'm constantly amazed and frustrated by instruments like this because as a keyboard player, my notes are always in tune, whereas on this thing,
I wish I could play cello, but I really can't. I wish I knew where the notes are. Cello not gonna pay my rent.
Okay, I'll stop. I apologize for all of that. Let's move on to the next instrument. Okay, so let's revisit the physics of the scale once more. So we know that if you cut a string in half, the pitch should go up an octave, but here's a Celtic harp. And on this Celtic harp, it doesn't seem like the strings exactly follow this proportion. So what exactly is going on? It turns out that the thickness of the string has something to do with how it manifests the frequency that comes out of it. So, although these are an octave apart, the middle see it around 261 hertz, 261 vibrations per second, if you will, would be doubled when you go up an octave. And again, doubled up an octave. And again, doubled up an octave. And again, doubled up an octave. But the thickness of the string and the tension on the string is part of the math of the system. So if you look at a piano is not, 30 feet long. And the reason is the lower strings tend to be thicker, the higher strings tend to be much thinner, allowing you a little bit of flexibility in how to tune these things. So you ask yourself, why? Well, when the first Celtic harps were being built, they didn't have nylon strings. They were using available materials, things like, the intestines of animals, catgut. And that allowed you to tune the string, and you'd use your ear to put them in relation according to that overtone series. Right, so let's look at the physics of a vibrating column of air just a little further. Here's an instrument based on a vibrating column of air. This is an English Baroque recorder. In this case, a tenor English Baroque recorder. This is a modern version. It's made of plastic. More traditional versions would be made of a hardwood, oftentimes a fruit tree like pear tree or apple. So I'll take a classical theme. In this case, some of you may recognize this is Giacomo Puccini's theme from Turandot, and I guess we should point out that he actually took that from the Qing Dynasty in the 1700s, better known as Mo Li Hua, if you're from a person who's into Chinese music. But here's the theme. So as you get into the lower register, you can see that as the length of the vibrating column of air gets longer, the pitch drops. In this case, this is a C tenor recorder, so it's an octave below middle C, or about 130 vibrations per second. If you had to predict what would happen if you played this instrument, and you can see it's exactly half the size, based on what we saw on the bass, it should be basically an octave higher. Let's give it a try. And you can see that we've jumped up and doubled the frequencies of all of the notes. So what would happen if we took an instrument of an intermediate size? Well, according to the overtone series, here's one that's based in F, an alto recorder. And you can see that the length of the instrument, the length of the vibrating column of air, has a great deal to do with the pitch that's going to come out. So let's investigate just a little further. So one of the great things about the keyboard is it's very easy to see the difference between a whole step and a half step. So in this lesson, where we're learning about major scales, and we're learning about the pattern whole, whole, half, whole, 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 half, the first thing we'll do is teach you how to recognize a whole step and a half step. This would be defined as a whole step. You can clearly see there's a note in between. This is a half step. There's no note in between. What would this be? And the answer is, of course, it's a whole step because, as you can see, there's a note in between. How about here? You can see that's a half step. There's no note in between. So to build a scale, let's start on C. Whole step, whole step, half step, whole step, whole step, whole step, half step. So we've just played a major scale. It turns out if you use this pattern, no matter where you start, you can build a major scale. Let's start on not D, not C, but D flat. So here we are in the key of D flat. D flat, whole step, half step, whole step, whole step, whole step, half step. It turns out building a scale, if you know the formula, is an easy thing. In later lessons, we're going to learn about the circle of fifths, which is a formulaic way to look at this, an easier way to build the circle of fifths. But right now, as long as we remember the pattern, whole, whole, half, whole, 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 half, we will be able to build all 12 major scales.
I don't feel tardy. Yeah, time to take you to school. Hurd class.
Learn